All right, so the last non-experimental sort of design we're going to go into here is a developmental or longitudinal design. So these can be used for a number of different things because it's useful to track things over time for a lot of different research questions. For example, you might use these in like political or sociological studies to see how attitudes and policy preferences change over time. But in psychology, frequently, the most common type of longitudinal design is going to be referred to as a developmental design. Developmental psychologists obviously are looking at how people change in their behavior and thinking and all sorts of things as they age. And you can't manipulate age, obviously. You can't randomly assign someone to a particular age. So you can only study these things through observation. But you can study them as people age or in people of different ages and compare them. So developmental designs, they don't have random assignment. And in essence, they boil down to something like an observational or a correlational study because you are not able to manipulate anything in a developmental design. Or, well, to be more specific, you can manipulate things in developmental studies. You can assign people to different conditions, but the real variable of interest for developmental psychologists is often age itself, and you cannot manipulate age. So you're basically looking at changes with age, and that key variable is not something you can manipulate. So if you can't manipulate it, how can you study age? Well, there are two main ways that you can study changes associated with age, and these are cross-sectional designs and longitudinal designs. Cross-sectional designs are designs where you are using different groups of people, different cohorts, different cross sections, if you will, of age groups. So ideally, you are randomly assigning people, or sorry, you are randomly selecting people. See, even I make mistakes with that sometimes. From a population from different segments, age segments of the population. So you're going to have different participants in each age group. You're not comparing people to their younger or older selves. At one time, you are selecting people from, a 10 to 15, 15 to 20, 20 to 25 age group to make comparisons between those groups. The advantages of this are that it is relatively fast and cheap and easy to do. Of course, like any research endeavor, there are costs and time associated with it. But imagine that you want to study the different attitudes about people to some particular outcome, and you just select people from different age groups. You measure their attitudes and you compare those different attitudes and see if they differ between those cross sections of the population. So it's very cheap and very easy and fast compared to the alternative. The problem with these types of designs, though, is that you have a lot of things confounded with age. You have people that have had different historical experiences, people that have had different political histories, people that have had different types of educational experiences. If you notice a difference between 20-year-olds and 70-year-olds in some sort of academic ability, it might not have anything to do with age. It might be that the people that are 20 have been in school more recently, and the ways to teach them have been more sophisticated than somebody who, went to school in a one-room schoolhouse or something. So because you cannot really isolate the effects of age here, you can't really draw a cause and effect or a causal type of conclusion from these cross-sectional designs because of what I've described as these cohort effects or generation effects, the effects of these different groups of having had different experiences and historical context. So a cohort is just basically the cross sections are your cohorts. A cohort is just a group of people born at the same time. And cohort effects, as I've described, are the unique experiences of those people. For example, people that grew up during the Great Depression when things were very, very scarce have different life experiences than people that were born in the, let's say, like 1950s or 1980s, when things were more abundant and the economy was much better. There might be lasting differences in how people from those different age groups interact with and experience the world because of the way that they grew up. So cohort effects can have very impactful outcomes in what you're observing. The alternative to a cross-sectional design then is a longitudinal design. Instead of grabbing different groups of people at the same time, you're going to follow a single group of participants over a longer period of time. So you would recruit people for a study that is going to last years or even decades, and set up some sort of apparatus and research paradigm for them to be recontacted and tested over and over again. So the biggest advantage here is that using some types of statistical approaches, you can use a longitudinal design to infer causality, or at least a little more, or quite a bit more strongly than you can with a cross-sectional design. If you are following these same people and you're able to measure changes in variables and control for changes in other variables, we won't get into the specifics of what a random intercept cross-lag panel design is, for example, but that's like one way that you can use equation modeling to actually show that there are causal relationships between your variables over time. And this rules out the issue with a cohort effect. If you're following one group of people over time, you know that it's not something about that you're not observing a cohort effect, because you don't have cohorts. You just have one group of people, and it's their development and their age that seems to be influencing changes in those variables. But that doesn't mean that the problems around cohorts are completely gone. Because you are measuring one group of people, it might be that that group of people is just very idiosyncratic in some way. So, for example, I use the Depression era or kind of boom periods later on as an example. If you were doing a longitudinal design that only had people that grew up during the Great Depression, then you would make some conclusions that are specific to that generation again. So generation effects still kind of matter, because whatever you're concluding from your particular longitudinal design might only apply to that generation. It might not generalize to other people, but you might be able to say confidently that within a particular generation, we see causal effects. Like the influence of different policies or public health endeavors led to changes in attitudes and behaviors in this particular generation over time. The most obvious disadvantage, in addition to those generational types of issues, is that it takes a long time. It takes as long as it takes people to age. So if you want to see, how going through junior high affects people on some measure, you have to wait for them to go through junior high and keep measuring them and taking, measurements and readings over and over and over again. So, there are some longitudinal studies that have been going on for literally decades, like the Minnesota Twin Study of the U, for example. That's been going on for, I want to say it's coming up on 40 years here pretty soon, that they have been measuring people's, attitudes, behaviors, health, things like that, to study different genetic influences because of, the way that we can infer things from how related twins are compared to other people. So there are lots of really good examples of longitudinal designs that have gone on for a long time, but remember that they're extraordinarily expensive, because you need to administer these things, keep track of people, contact them, recontact them, follow up. You need to do all sorts of things to keep them interested and compensated and aware of what's going on. Another problem is that when you are studying any group of people over a long period of time, some of them are going to die and some of them are going to quit. So you might have problems with your internal validity because people might be leaving your study for a particular reason. Like if you're studying the effects of responsibility or something and conscientiousness, well, some people are probably going to quit your study because they're not very responsible or conscientious. So it makes it difficult to study the effects of a variable when it might be related to the types of people that are quitting. Same with different types of health outcomes. In general, people that are less healthy are more likely not to survive. So when people die in longitudinal studies, it might distort your results because you're not able to observe people that are less healthy or more at risk of death. Um, Other things that might happen that are, maybe still problems, maybe less dire. If you're measuring things over time for people, there might be practice effects. So if you're studying intelligence and you're constantly having them do problem solving tasks and cognitive assessments, people might just get better at those things because you're asking them all the time. And it might not be a really normal experience for people to do those things outside of a study. So they might just get better, on the particular test that you're doing. Maybe people just get really good at abstract puzzles, but they're not actually getting that much smarter or something like that. So there are practice effects. Participants also might try to be consistent over time. I've mentioned that for some of you doing some repeated measures designs for your group projects. If you measure something and then have a treatment and measure it again, there could be, and there likely are, efforts to stay consistent. People want to seem like they're, reliable and consistent, and they might just give you the same answers from measurement 1 to measurement 2. And the same might happen even on a longer time scale. If you're recontacting someone every year, but you're giving them the same scales to respond to every year, they might over time start to remember those scales and they might just give you the same answer because they're used to it. And that can undermine your ability to really be able to see what's going on with your variables. And of course, like any type of study, there are issues of reactivity or those Hawthorne effects of just being observed. So whenever you're observing anyone and they're aware of it, it can affect what's going on. And for people that are in a longitudinal study that are used to being recontacted over and over again every few months or years, those things can still influence people's behavior. So cross-sectional studies have their drawbacks because you can't really tell if it's because of the generation or because of the age. Longitudinal studies have their drawbacks because they solve some of those problems, but they are extraordinarily time-consuming and expensive. One thing that you might do to get around both of these issues in a way is to combine cross-sectional and longitudinal studies. This is referred to as the sequential method. So if you look at any one of these rows or columns separately, it would constitute like a study on its own. So we're looking at birth cohort here. If in, let's say in 2025, you ran a study with people born in 1970, 1980, 1990, and 2000. This would be a single cross-sectional study of people at this time, the green column here at the end. The blue column, could be its own cross-sectional study, right? Just conducted at a different time. And if you were just looking at the birth cohorts here and you were following people over time when they were 25, 35, 45, 55, that would be a longitudinal study. But if you take the same group of people, if you collect different birth cohorts and then follow all of those birth cohorts over time, then you are, combining these designs and you're able to then rule out some of those alternative explanations from the weaknesses of cross-sectional and longitudinal designs. If you see the same sorts of trends in your people born in 1970, same trends in people born in 1980, 1990, then you are able to say more confidently that this isn't something about the particular generation. It's not something about how a particular generation is reacting to a particular point in time. You're able to combine these things to rule out those alternative explanations. However, I've been saying that longitudinal designs are extraordinarily expensive. Well, just imagine that you're doing 4 or 5 longitudinal designs at once, right? That makes it even more expensive and difficult to administer. So there are very few examples of this type of study that go on for a sizable length of time. But this kind of represents the best way that you could do a developmental design, even though it is an onerous and expensive thing to be able to do.